Okay, so let me start with the first example of the least square adjustment. A specific variable is measured 8 times at 8 different times of the day, t. The variable is s. Our goal is to define a model that represents the best temporal distribution of this variable in order to be able to calculate the value for any other time in between those already measured. So this is a temporal adjustment. Yeah, it's not a spatial adjustment. It's a temporal adjustment where the variable s is can be anything. For example, a temperature, and the explanatory variable is the time. We are going to use a third order polynomial as a functional model. So you can see that the model, the general model will be on that way. With a0 plus a1t plus a2t squared plus a3t cubic. And this is our model. So let's identify the data we have. We have first the collected data, which is S, so 363211116, and then the time, which is the explanatory variable for this specific for the moments where this S data was collected, 1, 3, 5, 7, 8, 10, 12, 15. So first step, identify our vector of observations, or vector of estimates, and our matrix of coefficients. Yeah. So the vector of estimates is basically an empty vector or a vector of unknowns that we need to calculate, but we need to name them at this stage. The vector S is already the vector of observations, and the vector A is the vector of the matrix of coefficients. How is this matrix of coefficients be designed? According to our model, the model we have created. So at this stage, we just need to enter the terms, the symbols, not the numbers. Yeah, this is the point number one. But since the model have this format, the vector of coefficients will also have this format, but 10 times repeated according to the functional model or the number of observations. Point number two, functional model. Here is where we enter the numbers. Yeah, first we enter the numbers in the formulas and then in the matrix. But what we have to enter in the matrix is what is coming from the formulas. So in the first formula, formula of polynomial formula of our model, we enter the first observation, which is 3, yeah, and then we fill the t values for the model. In that case, t corresponding to first observation is 1, yeah. So basically we substitute t by 1, yeah. But keep in mind that the first coefficient is always multiplying 1 because there is no t attached. Yeah, so the first one will be a0 times 1 plus a1 times t, which is 1 because the time is 1, times a2 plus a2 times t squared, which is 1 squared, plus a3 times t cubic, which is 1 cubic. So this is 1, 1, 1, 1. This 1, 1, 1, and 1 on the formulas. And then we repeat the same process for all the observations, but taking the corresponding t value. Yeah. And then we build our A matrix or coefficient matrix, which is the most important element in this calculation. And this is how we create our functional model. And then the adjustment step, which is a matrix calculation, we just need to apply this formula, A transpose times A invert times A transpose times S. And this is this, if we apply well this formula, this matrix equation, will get a vector of observation which is x hat. Yeah. And this is the result. And then we just need to enter these numbers into the original formula, this formula, the original one. And now we can enter any t, any time, and we'll calculate the corresponding temperature. Yeah, so this is how we generate our model. An example is the application step, point number 4, where we enter any time which was not given before as part of the observations, and then we calculate the corresponding value of the variable, which is 1.4 degrees or whatever. Yeah, and we should also be able to calculate the residuals. So how good is our model? Yeah, remember, according to the theory, these residuals are minimized due to the use of least square theory. Okay, so this is the point number 4, the exercise number 1 for the least square adjustment. One thing which is missing, I I still have to explain, but I will upload a video tomorrow, is how to do matrix multiplication and matrix transposition and matrix inversion. This is something you should explore. This is your homework for today, to again go through all the exercises, understand how they are done, post your questions again, and send in one the sheet, okay, just handwriting, example of and the theory and the example of matrix multiplication, yeah, and then I will complete what you sent to me tomorrow with a video, with another video, just to explain to you how to perform manually this this step, the step number 3. Okay, let me stop it here, and then we'll cover the last exercise, the last example in the next video.